Vent valves locked.
T-minus 1 minute.
Rock, report range status.
Rock, range is green.
Roger. .40.
Stable at step 3.
T-minus 30 seconds.
28. 25. Status check.
Go Atlas.
Go Centaur.
Go L-55.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket carrying the NROL-55 mission for the National Reconnaissance Office.
We have booster PU to close loop control.
You're hearing the voice of Rob Gannon providing launch vehicle ascent
Everything
data.
looking good. The RMR valve position looks good. MTU shaft speed looks good. Flight control is nice and clean, seeing normal disturbances for this time of flight. Main engine continues to operate normally. Vehicle is now flying at half the speed of sound. We are 3 miles in altitude, 0.3 miles downrange, traveling just over 1,000 miles per hour. RD-180 continues to burn normally. Up on Mach 1. L-55 is now supersonic. Flight control continues to be nice and smooth, RD-180 operating normally. We have throttled down to 95%, right on time. Nice and smooth. Two minutes into the mission, everything looking good. Started Q alpha limited steering. RD-180 is burning normal. And the vehicle now weighs 50% of what it did at liftoff. 22 miles in altitude, 20 miles downrange, traveling at 3,000 miles per hour. Just continue to burn normally. And we fired the pyro valve, pressurizing the second stage reaction control system. Pressure is rising as expected. Next event we're looking for, throttling down to 92% thrust. Expect that in 10 seconds. And we've got the throttle down, engine continues to burn normally. Parameters look good. Passing through 200 seconds in the mission, everything looking good. Vehicle now weighs 1/4 of what it did at liftoff. 52 miles in altitude, 107 miles downrange, traveling at 7,800 miles per hour. And we've begun boost phase chill down. Preparing the RL-10 for main engine burn on the second stage. RD 180 is throttling down. Preparation for BECO. Boost phase chill down has completed. BECO. Booster engine cutoff. Coming up on stage separation. And we have stage separation. Looking good. Pre-start on fuel, pre-start on locks. Ignition, full thrust. The RL-10 is up and running normally. Good start signatures. Coming up on fairing jettison. And we have fairing jettison. Both brake wires indicate a good jettison.
This is Atlas Mission Control at T plus 4 minutes, 37 seconds. We've just seen the successful liftoff of the ULA Atlas V carrying the NROL-55 mission for the National Reconnaissance Office. As I mentioned earlier, today's mission is also carrying 13 CubeSats sponsored by the NRO as well as NASA. And I'm pleased now to be joined by Andres Martinez, the Deputy Program Manager for Small Satellite Technology for NASA. Andres, thanks so much for joining us this morning.
Thanks, Matt. That was a great launch, and I'm very excited. The optical communication and sensor demonstration, also known as OCSD at NASA, is the first of 6 missions for our program. And in the next 9 months, and today was a great start. OCSD will be demonstrating for the first time on a small satellite laser communication.
That's really exciting to hear about the kind of capabilities that we're able to take to orbit with these CubeSats. So why is NASA so interested in these kinds of technologies and small sats, CubeSats?
Small satellites provide NASA the ability to rapidly develop and launch groundbreaking technologies into space. At NASA, we have also been using small satellites to conduct fundamental space biology for over a decade now.
It's amazing what you can do with a small satellite. So this is actually the first of 2 that are currently in the plans. Why is this mission so important to NASA to demonstrate this optical communication and sensor capability?
Yes, this is the first of 2 OCSD missions. The second one will be in about 4 months. Laser communication will provide small satellites the capability of significantly increasing the amount of data we can download from space in a very short period of time. For example, during my last space mission, it took us over 100 days to download just half a megabyte. OCSD will accomplish that within seconds.
It's amazing the leap forward in technology. So tell me a little bit more about how the spacecraft is going to be able to interact with the ground station.
Sure. We have a ground station on Mount Wilson near Pasadena, California. OCSD will be using its very sophisticated attitude control system to align itself with high precision as it passes over Mount Wilson and its ground station. And it's going to beam a laser from 600 to 700 kilometers up in space, and it will hit a target that's only 30 centimeters wide. That's pretty incredible.
That is amazing. So how will this kind of technology enable future exploration with NASA?
Laser communication is being investigated to also support deep space missions like Mars, for example. OCSD demonstrations will provide quite a bit of data so that the technology can continue to be matured.
So these tiny spacecraft demonstrations, what do you see as the future going forward for this kind of capability?
You know, the small satellite technology capability has been leapfrogging. It's moving very rapidly, and, you know, it's gotten the attention of NASA and other agencies and the commercial industry. In the future, we see swarms of satellites supporting the bigger missions as scouts. And so, you know, for that, we need to continue to advance the technologies.
Well, it's really exciting. Thanks so much for joining me this morning, Andres. I wish you the best of luck with OCSD. We had a great start this morning.
Thank you, Matt. Thank you for inviting me, and I wouldn't be anywhere else. Thanks. This was a great experience.